going to cover the basic of matrices. First I am going to define the matrices. A matrix is in fact a rectangular arrangement of different elements. I am given with some elements here arranged in this way. If we consider such arrangement where some lines are there, the horizontal lines represent rows and some columns are there. Vertical columns that are vertical lines represent column. In this way, a matrix is the arrangement where rows and column forms a rectangular pattern. That means a matrix is the rectangular arrangement of rows and columns. That means horizontal lines and vertical lines. Horizontal lines and vertical lines form order of a matrix. That is defined as number of rows cross number of columns. Right now in this case 3 rows are here and 4 columns are here. The order is 3 cross 4. In this way we can determine the order of a matrix. Let's start with rectangular matrix or rectangle matrix. A matrix is said to be rectangle matrix if number of rows are not equal to number of columns. If I have a matrix of this form where number of rows are 1 and 2 and number of columns are 1, 2, 3. That means it is 2 cross 3 matrix. Many times we represent in this way. Number of rows are not equal to number of columns, then such a matrix are called rectangle matrix. Then we have square matrix. Square matrix are those matrices where number of rows and number of columns are equal. Many times we just say 3 order matrix. We don't need to mention both the rows and columns because in a square matrix the number of rows and columns are equal to each other. We just have to say 3 order matrix. That simply indicates it is 3 cross 3 matrix. In case of a square matrix we have principal diagonal. It indicates the principal diagonal. And these elements are principal diagonal elements. These 3 elements are called upper diagonal elements. And these remaining elements are called lower diagonal elements. In this way we define a square matrix. The third type of matrix is diagonal matrix. Diagonal matrix is a square matrix where only diagonal elements are present. All other remaining elements are 0. Only diagonal elements are present. Rather you should say the principal diagonal elements are present. This is the diagonal matrix. It is obviously a square matrix where only principal diagonal elements are present. Now we consider scalar matrix. Scalar matrix is a diagonal matrix where all the diagonal elements are same. Let's say A, that means they are going to be A and A only. This is Now we consider identity matrix. Identity matrix is a diagonal matrix where all the diagonal elements are 1. And if it is diagonal, that means it is a square matrix as well, because the diagonal matrix is a square matrix. It may be of order 3, and if it is of order 3, it is often represented in this way. If it is of order 2, it is often represented in this way. It is also known as unity matrix, as its determinant, if I represent it by capital A, its determinant is going to be 1, and hence it is also known as unity matrix. The 6th type of matrix that we are supposed to deal today. Okay, remember one more thing. Normal form operations are accomplished by using identity matrix. The 6th type of matrix that we make use of is lower triangular matrix. Lower triangular matrix is represented by capital L, and it is a square matrix whose upper diagonal elements are 0. Obviously lower diagonal elements are present, but upper diagonal elements are 0. The 7th type of matrix that we deal with is upper triangular matrix. Upper triangular matrix are often represented by capital U. These are the matrix whose lower diagonal elements are 0. We have upper diagonal elements PQR, but lower diagonal elements are 0 here in the case of upper triangular matrix, and we make use of upper triangular matrix in echelon form operation. Later on we will make use of echelon form and normal form. We make use of normal form to find out the rank, and rather we use echelon form to solve the simultaneous equations, simultaneous linear equations rather. In echelon form operation we make use of upper triangle. We have null matrix as well. Null matrix are those matrices whose all the elements are 0. That means its determinant is also 0. In this way we cover the basic types of matrix that we are going to use later on in our discussion. In next lecture we will cover the rank of matrix by using determinant technique and by using normal form operation. And then we will cover the solution of simultaneous equation by echelon form. Okay, this is the basic types of matrix that we have discussed, that we must understand and know before starting the rank and further topics.